Good afternoon. I am Ashish Ranjan and I am going to deal with the refrigeration and air conditioning PPT. Now, what is the objective of this PPT to go through? One is basic operation of refrigeration and air conditioning systems. Second, principal components of refrigeration and air conditioning system. Third is thermodynamic principle of refrigeration cycle. And the last one, which is we are going to deal with, is safety considerations. Now we are going to see the first thing, which is uses of systems. First, cooling of food stores and cargos. Second is cooling of electronic space and equipments. And the examples of electronic spaces which requires cooling is computer and consoles, radio communication gears, radars, sonars, etc. Third is the cooling of magazines, and last one is air conditioning for crew comforts. Now, definition review, we are going to see what is the things around. Specific heat, which is denoted by CP, amount of heat required to raise the temperature of the substance. Now, second is sensible heat versus latent heat, and the last one is second law of thermodynamics on which the refrigeration system works. Refrigeration cycle is the next. What is refrigeration? First of all, we understand what is refrigeration. Refrigeration is cooling of an object and maintenance of its temperature below that of the surrounding. Working substance must alternate between colder and hotter region. This is the basic principle from of the refrigeration, which brings heat from respectively colder region and eject it to the hotter region. Most common cycle which is used is vapor compression cycle. This is the reverse of power cycle. Heat absorbed in low temperature region and released in high temperature region. This is the generic refrigeration cycle diagram, which works between high pressure side and low pressure side. Okay, the higher pressure side is used. This part is condenser and receiver, which came from the expansion valve where the refrigerant expanded and enters into refrigerator. Evaporator is also called, and from evaporator where cooling is take place, it went to the compressor and again compressor to condenser. This is the overview of the cycle. Now the cycle above cycle works on the thermodynamic cycle. This is the wet region, as you know, and this is the subcooled region, and this is also called a liquid phase, and this is the vapor phase, and here the superheated vapor is existed. Now this is the over diagram of refrigeration system, and this is the condenser we are discussed with. This is also called chiller. From condenser, this is the expansion valve or port. From expansion valve, the refrigerant came to the pipe to the receiver, and from receiver to the condenser, and condenser to the compressor, and can come from compressor to condenser. Now we are going to discuss the parts of the refrigeration system. First of all, we are going to discuss components like refrigerant, evaporator or chiller, compressor, condenser, receiver, thermodynamic expansion valve. Now, what is the refrigerant? Refrigerant must be having high latent heat of vaporization. It means maximum for the maximum cooling, non-toxicity, because we are sometimes we this is open to the eating substance. Desirable saturation temperature. Chemical stability, it means it must not be flammable or explosive. And ease of leak detection of leak must be easy, and cost of the refrigerant must be low and easily available. Commonly used refrigerant is Ferron, like R1, R114. Now second part is evaporator or chiller. It is located in space to be refrigerated. Cooling coil act as an indirect heat exchanger. This is the coil which takes heat from one part and send to the other. This absorbs heat from surrounding and vaporizes. And third is slightly superheated. This region is slightly superheated, and this is the overview of the chiller or evaporator tubing. This is the situation where the tube is assembled in evaporator. Third part is compressor. This is the compressor where the superheated vapor exists. When a refrigerant enters into this part, it is at low pressure and low temperature. But when the refrigerant extracted outlet of this compressor, the refrigerant exists at high pressure and high temperature. It means the temperature is increased in compressor, which promotes heat transfer, and also pressure is also increased in this compressor, and increase in energy provides the driving force to circulate refrigerant through the system. Okay, the next part is the condenser. Refrigerant reject heat to the cooling medium. Latent heat of condensation is also there. Indirect heat exchanger, it means seawater absorbs the heat and discharge it to the overboard. Okay. The last part is receiver. Second last part is the receiver. Temporary storage. This is the temporary storage space and surge volume for the subcooled refrigerant. Serve as vapor seal to prevent vapor from entering and the expansion valve. Expansion device. This is the last part. The thermostatic expansion valve. Liquid pheron enters the expansion valve, and the control system of this device is the pressure reduction. Amount of refrigerant entering evaporator controls absorbability. This is the layout of thermostatic expansion valve. All right. Now we are going to go to understand what is the air conditioning. Purpose: maintain the atmosphere of an enclosed space at a required temperature, humidity, and purity, so that the occupant must feel comfort. Second, refrigeration system is at the heart of air conditioning system. Heaters in ventilation system, and the types which is used in air conditioning system is self-maintained, contained, refrigerant circulating, and chilled water circulating. We see one by one. First, self-contained system, add to ship that originally did not have air conditioning plant. Second, refrigerant circulating system, which hot air passed over refrigerant cooling coils directly. Chilled water circulating system, refrigerant cools chilled water and hot air passes over chilled water cooling coils. Alright, this is the basic layout of the air conditioning system. As we discussed here, this is the condenser, and condenser from the receiver comes to the chiller, and chill from the expansion valve. This is again the circulation take place. Now the last is the safety precautions. For the what is the considered in safety precautions? It should be first gas hazard, the lethal created when refrigerant is exposed to the high temperature, and second is handling procedure, means when we are going to handle the system, we have to wear goggles and gloves to avoid eye irritation and frostbite. Asphyxiation hazard is non-ventilated space, and the last is handling of compressed gas bottles. These are the safety precautions which must be considered during the handling of the system. Now about the questions we have assembled in the class, and whatever we are going to, you having any queries, if you have any queries, you can contact me in the class. Thank you.